When you make a current in a wire due to a magnetic field, you do it in one way only. This way was discovered by Faraday and Lenz. The work on magnitude was done by Faraday, and the work on direction was done by Lenz. Faraday discovered that the size of the current induced in a wire was proportional to the rate at which magnetic flux was cut. If you cut a field line, you'll generate a current in the wire. If you slowly cut a few field lines or a few flux lines with a wire, then you'll induce a small current. If you speed things up and cut lots of field lines, you generate a larger field and a larger current in the wire. There are three ways to increase the rate at which magnetic field lines are cut. The first is to move faster. Make the wire move through the field faster by giving the wire a higher velocity. Increase the flux density by using a stronger magnet, meaning there are more field lines to be cut per unit area at the same velocity of wire. Or finally, increase the number of wires or loops in the magnetic field, so increasing the number of wires that cut one line. Of course, you could increase the size of the current even more by making the magnetic field and the wire move relative to each other. Set both the loops of wire and the magnet on spindles and spin them in opposite directions. Now the wire will move towards the magnetic field lines and the field lines will move towards the wire. This can all be summed up mathematically as the magnitude of induced current is equal to the rate of change of flux linkage, which is equal to n change in phi divided by change in time. Electromotive force is the name given to the force which makes the electrons move in the wire from Fleming's left-hand rule. It's this force that generates the current. We are just left now with the direction the current will go in, and this was discovered by Lenz. If you spin a metal disc in a magnetic field, the disc will slow down. It slows down much quicker than it would do if it was just exposed to friction. The metal disc generates its own magnetic field within it. It was Lenz's work which showed that this induced magnetic field worked to stop its own generation. If you spin the plate clockwise, then a field would be created to generate an anti-clockwise force, and vice versa. The field created in the metal plate is opposite to the field generating the field. This means that the fields act against each other, and also means that the direction of any electromagnetic force, and thus current, is negative compared to the direction of motion. Faraday gives us an equation to derive the magnitude of an electrical force, and Lenz gives us the direction as a negative sign to say it was opposite. This principle is behind magnetic disc brakes on expensive cars and can also be used as a type of flow gauge.